Let's look at plotting polar equations using Desmos. Of course, the first thing to do is go to desmos.com, click on Graphing Calculator. Now, you can graph in polar or rectangular just fine. You could type in something like r equals 4, and it knows what you mean if it's a simple equation. That is an equation with radius of 4. The weird thing is, of course, there's no theta in this equation. It just says r equals 4 because it doesn't matter what theta is. Any value of theta you put in, the radius is 4. If you want to see how that looks with a polar grid, just go over here to Settings, turn on the polar grid, and it'll put this in for you and mark circles radius 2, 4, 6, 8, 10 with the relevant angle lines as well. You can graph more complicated things. Sometimes, unless they've updated it, you might need to type in r of theta to start your equation. And keep in mind, to type a theta, I just typed theta and it auto-completed. So I could type in something like 4 sine theta, and it will give me this blue circle, which looks like a circle of radius 2 centered at 0, 2. But I could fancy this up if I want to and make a pattern that looks like that. Really, any thing I want to type in here, it'll go ahead and calculate for me. I could try to add a couple waveforms. I could do something like 3 sine theta plus 1 sine 5 theta. And I get something that looks like, I don't know, a rocket ship or something. But I could change these numbers if I want to. I could call this M and N, and then I could add sliders, and I could say, okay, what happens if we do that, and what happens if we do that? And I make all sorts of weird looking shapes for myself. And maybe it works better if I have this from 1 to 20 by 1s, and maybe I should have this one from negative 10 to 10 by 1s. And then I can just make some things that maybe look a little more regular. So I can make things that look like butterflies or leaves or whatever just by changing the values of M and N. That's a nice looking butterfly graph. I might use that one on my Christmas card. That's pretty much all there is to it. A lot of the online homework problems, if they ask you what the graph looks like, just come into Desmos and graph it. A few of the questions, you still need to convert them from polar to rectangular using the formulas that we looked at. But in terms of graphing them, just type it in here. Don't worry doing it by hand or anything. Sometimes they give you weird questions that they might be like this. They'll say something is in the form a times cosine n theta, and then they ask you what a and n do. So that's where you just type it in and add sliders. I went ahead and made these sliders go from negative 10 to 10 by 1 and 1 to 20 by 1. And then you can play around with A. A is amplitude normally, and you can see it is amplitude. It does make this bigger. And then what does N do? Well, N is the period constant if we were graphing a cosine wave. But here we're not. We're doing polar graphing, so it works a little differently. If N is 2, you get 4 petals on this rose. If N is 3, you get 3. If it's 4, you get 8. 5, 6, you get 12. So you can see the pattern here. If it's an odd number, you get that many petals, or n petals. If it's an even number, then you get 2n petals, like so. And the reason for that is kind of fun. If you think about graphing a cosine curve, it would start at its maximum and go to its minimum. So if you think about this being on a polar grid, you might have something like this. Well, it starts at its maximum when theta is 0. Cosine would be, in this case, cosine of 0 is 1 times the amplitude of 3, it'd be at 3. So theta is 0 and radius is 3. And then when theta increases, it goes to 0, then to its minimum, then to 0, then to its minimum. But keep in mind, when the angle's over here, the radius is negative, so you go over here. Well, I'm not sure I said that exactly right, but that's what you get. It's kind of a, if you sort of wrap a cosine curve around a polar grid where theta is what you're rotating by, and then you're graphing r instead of the x-coordinate, you get something like this. But that's pretty much it. Just go ahead and use Desmos for all your polar graphing needs. You might need to put it in r theta form.